Welcome one and all to the video on the law of cosines, where you will use this law to solve for all the measurements of a triangle. When it comes to solving oblique triangles or non-right triangles, there are 4 cases to consider. In a separate video, we focus primarily on case 1, where you use the law of sines to solve SAA or ASA triangles. Case 2 will be the focus of a different video. In this video, we will focus primarily on case 3, which are SAS triangles, and case 4, which is SSS triangles. Currently, at the moment, you see a review on the law of sines, as this will play a part again in the law of cosines at the same time. We also need to consider the alternative law of sines, where the sign of the angle is on top of the fraction and the side is on the bottom. Here we have the law of cosines, and these 3 equations hold as long as you have angles ABC for the triangle and the lowercase sides ABC. And these 3 equations will focus primarily on SAS triangles, or side angle side. And at the bottom of the screen you have a text which is a word-by-word explanation of each equation. This set of law of cosines alternatively focuses on the side-side-side triangles, or SSS. So depending on which case you're working on, one particular set will be beneficial over the other. Now when it comes to solving for each particular case, there are 3 steps to each one. Here we have the first step is to find the third side using the law of cosines for an SAS triangle, then find the smaller of the 2 remaining angles using the alternative law of sines, and then using the angle sum formula to cap it off. When it comes to SSS triangles, the first step is to find the largest angle using the law of cosines alternatively. Then step 2 is to find the either one remaining angle using the law of sines alternatively, and capping it off with the angle sum formula. So let's dive right ahead into our first example. This one you have triangle ABC with 3 measurements given to you, 1 angle between 2 sides, and we are asked to find side C, the third missing side. So right away we establish that we're going to use the law of cosines because this is an SAS triangle. Now, which equation we use depends on which angle we were given in the SAS triangle. So here we're given angle C, so therefore we're going to use this particular equation. We plug in all the known values, or substitute it in, and make sure that when you calculate it in your calculator, it's in degrees mode. So if you have it in radians, it will give you a different value. So here we have c squared is approximate to that large number. But remember, we're not done until c is completely by itself. So we take the square root of both sides. So our final answer to this problem is c is approximately equal to 626.6 meters. Now let's tackle our second example, which has multiple parts to it because we are asked to solve the entire triangle. We need to find all the measurements. So here we have another SAS triangle, side B, angle A, side C. So we're going to find side A using this equation because we're primarily given angle A. We plug in all our known values, and again, make sure the calculator is in degrees mode. We get a squared is approximately equal to 109.7. Take the square root of both sides. Side A is approximately equal to 10.47. We are not done, however, because now we need to consider which angle to find, angle C or angle B. Here I say we can find angle B since side B is shorter than side C. Well, how do you know that? Well, you look at the actual measurements of the sides. So you have 12.9 meters for side B, 15.4 meters for side C. So side B is shorter, therefore angle B will be smaller than angle C. So we're going to find B. So in order to find the smaller angle, we use the law of sines in its alternative form, where the sign of the angle is on top of the fractions and the sides are on the bottom. Sine A and side A is our complete pair, so we have one complete fraction. The other one is what we were looking for, angle B. Multiply both sides by 12.9, and you get that fraction. This is where you calculate it in your calculator, but make sure when you approximate it, it's in degrees mode. And we get that sine B is approximately equal to this long decimal number. However, we're not done because angle B is not completely by itself. We need to get rid of the sine function. So what we do is we need to take the inverse sine function. So I have this typed out for you, and in case you're wondering how to do it on your calculator, here's a quick snapshot of what to do. What you do is you pull up the keypad on Desmos app, go to the functions, and you have all these trig functions given to you, including the middle column, which has the powers of -1. That's just the symbol for inverse function. So therefore, I would use inverse sine. I would type in my large decimal numbers, so 0.8, I don't know what the exact numbers are, but you'll get your value there. If you do it on your graphing calculator, you could also just do this. There we go. So on the buttons right here, you have sine, cosine, tangent. We want to do the inverse of it, so you click on second sine, and that will pull up inverse sine. And you type in your decimal number there, click enter, and that will give you your answer. So here we go. We now have angle B approximately equal to 56 degrees. Now we can find the missing angle. And this last step is easy because once you have two angles found, you can just apply this angle sum formula to find the missing angle. So here's the angle sum formula. Plug in the two angles we know, which happens to be A and B. Combine like terms. Get C by itself by subtracting both sides by 98.3. And we get angle C is equal to 81.7 degrees. And that is the final answer to that problem. So we found all three angles and we found all three sides. The last example is going to be our SSS triangle. So this is where we're going to find the largest angle using the alternative law of cosines. How do we know which angle is the largest? Well, look at the sides and see which side is the longest. Side C is the longest with 21.1 feet. So therefore, angle C is the largest angle we're going to focus on. So here's the alternative law of cosines, where cosine C is by itself, and we have the entire fraction on the other side. We substitute all the known values in. Again, when you calculate it on your calculator, make sure it's in degrees mode. And we get cosine C is approximately equal to this negative decimal number. Again, angle C is not by itself. We need to get rid of the cosine functions. We apply the inverse cosine function. And here we have inverse of cosine. So just like the inverse of sine, you go to your calculator, find the inverse function, type in the decimal value, and we get the final answer of C is approximately equal to 109.9 degrees. Once you find the first angle, you can pick yourself which angle you would like to find. Let's just pick angle B. So we go to angle B, and we use the law of sine's alternative form to find the missing angle. So we substitute all the known values. We use, obviously, angle C and side C because we just happen to find the angle C, and we are already given the side, so that's our complete pair. Multiply both sides by 15.9, and you have this fraction. Use the calculator to approximate the decimal value. Make sure it's in degrees mode. And we have this decimal number. But again, we need to get angle B by itself by applying the inverse sine function. So you type this in your calculator, and we get our final answer of B is approximately equal to 45.1 degrees. And we're almost done, so now we find the missing angle. And to find the missing angle, you apply the angle sum formula, which is right here. So if you look at the right side, I have all the angles and the sides given to us written there. Now we can find the missing angle of A. So we plug in all the numbers we know, combine like terms, subtract 155 on both sides, and the final answer is C is equal to 25 degrees. And there you go, ladies and gentlemen. That is how you find, or that is how you apply the law of cosines.